Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Well, welcome to our Tips and Techniques SolidWorks series. This is episode 10, Advanced Part Modeling 6, and we're going to continue to talk about the boundary feature. And in this episode, we'll be covering some more properties of boundary, some options, how to do selection using the selection manager with boundary. And then we're going to do a deep dive into these two models, this sound dock model that I created a number of years ago, and then this Impellor design that I just did recently, both of which use the boundary surface quite prolifically. So why don't we just get back into SolidWorks and we can take a look at some of these features, and then we'll get into some of these models and show how the boundary feature is used for both of those. So the first thing I want to cover is a little bit more about the features of boundary, and namely selection and using curves to create boundaries. So here I have a very simple model that is created using one 3D sketch with a number of 3D sketch curves in that single sketch. And we're going to use the boundary surface to create a boundary for part of this. So if we just start selecting curves, and again with the selection manager you can pin it, so every time you use create a boundary surface or boundary feature, this will come up. It'll come up automatically. If you have a 3D sketch or a 2D sketch that has more than one curve entity in it that wouldn't qualify for a single direction, it'll automatically come up. So I'm going to pick these as my first direction curves, and then for my second direction I'll pick these two. And you can see that right now it's creating a generalized boundary from those four curves, and that's why it drops off here. I haven't included these outer curves as the boundary. But this shows off the ability to trim by one or two directions. So here I'm trimming by the first direction, and here I'm trimming by the second direction. But there's other ways to do this also. So if we just clear our entries for both, and let's say that we want to create this, we want to create a partial area using these curves, and say it's not as well defined as this example model. Why in Selection Manager you have these meatballs that you can move back and forth, and they do actually snap 2 points. So you can make them parametric. You can put sketch points previous to creating your boundary and have them snap. And let me do the same for this one. And you can see that it limits the boundary just to those points that you moved in the sketch. Let's do a third one here. And then you can also do that for the second direction. So looks like we have an order problem here actually. So we need to take this curve and move it up so it's actually in the right area. So you can see it's kind of looping back on itself. So actually this curve needs to move down. There we go. So we get our order correct. Let's go in the second direction and do the same thing. So we're going to drag our meatballs here. And I'm doing this just to illustrate an issue. So there's an error there. There's an error there because in my first direction I have these curves selected, but I've taken this one and dragged it beyond there. So it really doesn't know how to create that solution. And again, it's still confused. Let's clear that, reselect it, and let's see if we can drag these. Okay, yeah, that works. So we're going to do that again here, and again you can snap these to selections and do the same for this one. So there you see that I've done my specific selection within the selection manager to show what I want. And then if we start excluding sketches, or if we again use trim by 1 and 2, we get something that's more predictable, even though we've stretched these out here. So that's a little bit about how to do selection and use generalized curves to create a specific boundary solution. Very handy because it really cuts down on the amount of features you need to do in SolidWorks, and you can use almost just any collection of sketches or edges and sketches in combination to build your boundary surfaces. So let's get into a little bit more about boundary and what options are available to us. So I have this sound dock model. Actually, this is the master model for that. And if we roll back to the main form and start to take a look at how this was created, one of the very first boundary surfaces is illustrated in this reduced model here. So I'm going to go to that here and show how I did this. So these are some of the primary features here. This is basically a revolved surface that is created over here and then mirrored, and then the handle is a loft that we've built to loft in between these two. Maybe I'll just roll back to that one and show that. So if we edit into that boundary, here we have a boundary that is created between 3 first direction curves and then 2 second direction curves. If we take a look at that just straight on from the top and we clear these, you can see that the reason I did these second direction curves is I wanted to get a more distinct shape to that handle. Now, you don't necessarily have to use second direction curves, and in some cases it's advantageous not to, because you're going to get a better equal curvature solution at the first direction curves. I'll show that a little bit in the next boundary and why that's important. But here you do have some options. If you want to keep a very good curve continuity here at these boundaries, you do have the ability to weight these boundaries to maybe change that profile a little bit more. And so here I'm taking on these two to give it a little bit more weighting to them. And if you make them equal, you get close to the solution, but you can also see it's not quite doing what I wanted to do. I wanted a more uniform, some circular pattern through the middle. You can also weight the middle one, which is interesting. If you do it normal to profile and then weight that, let me put that in there, and then weight that one, then we can start to weight that profile. But again, you can see you don't have as much control as if you had your second direction going on there. So just a little bit about how you can use those controls in the property manager, that is the weighting value here. Now, that does not work if you have second direction curves, because remember the second direction curves are actually defining that weighting. So yeah, it's just a little bit, it's really not going to be very advantageous to weight those areas because of the second direction curves. So let's exit out of that. Let's go forward to the next boundary, which is down here, that I have yet to create. So I want to fill this area in between the two speakers. So I'm going to go ahead and select these edges. And this will be my first direction first curve, first direction second curve. And right now I have no matching. If I go ahead and create a matching with curvature, the solution you get here is happening because it's deriving the curvature from the isoparams of these two surfaces. And if you remember, I mentioned these are revolved surfaces. So the isoparams would be coming out radially from the center of this revolve. It's namely the same. If I just align with isoparam of each, you're not going to see any change, because that's really what's happening. Is you have it being derived from those surfaces. And that's actually the solution that I used to create this sound dock model. I actually accepted that. And then I used these two surfaces, these two curves to trim that away. And I did that because I got a very, very good curvature matching here across or between these two surfaces. But just to explain a little bit more how this works, let's say that, for instance, we were to include an interim curve here, which is right here, and we just reorder that, so that's now in the middle. So what we have going on here now is we still have the same curvature being derived from these surfaces, but now I've included this one. Let's see what we can do with that. If we're to go and assign the directional vector of this curve, let's turn off our selection manager, and make that that vector direction off this axis. You can see a slight change, and you get a little bit more influence through that middle curve. But we still have a problem here in that I doubt this is going to actually resolve as a feature. Yeah, because what's happening here is that there's a kind of pinching going on at these corners, and there's probably an intersection or overlap of the actual surface. So if we just clear all this again, let's go ahead and reselect these, and let's go ahead and create our curvature. Now, if we wanted to use that solution but kind of match this center curve, then we can do some weighting. So we could go into each of these and weight them a bit. So I'm going to do 1.4 on both of them. And now you can see I've gotten it closer to that center curve there. But you can see it kind of creates a dome towards the middle. So we can maybe back off that a bit for each of those. Okay. And that would be a great surface to use and then trim away. Let me explain a few more things here. So we have our drop down here, and remember this only applies when you have first direction curves, or if you're just selecting down in the second direction. Again, we have align with isoparam, which is essentially is the same as with other geometry. And if we wanted to use next section, that's not going to change much. We do that for both. You can see that what it's really doing is it's just giving you a linear solution. And that really is better highlighted when you have this curve right here. So unfortunately, when you do include that option goes away. So this could be an acceptable surface, and it does rebuild. So it's just nice that you get those various options to get different solutions, and you can actually control how the surface is flowing and what it's matching when you create this boundary between these two. So let's go in a little bit deeper into some of the properties for boundary. So we're going to bring up this surface that I just created and just go down the list here. So I talked a little bit about aligning with other geometry when you have some kind of matching condition, as we have here with this curvature for both of them. And we've talked a little bit about weighting these, and here I'm weighting each of these. You also get the option to actually add draft basically to these features, and if I wanted for some reason to actually add some draft, I can do it there. If we go down a bit, merge tangent faces, let me explain that a bit with another model here. And we're going to bring that up. So we have a boundary here. Let me just delete that and show it recreated. So if we turn off our selection manager and just pick these two sketches. Okay, and then we have a third one in here in a second direction, which is a 3D sketch. And if we use the default solution, you notice that those sketches are made up of multiple entities, but yet the boundary solves as one surface. That's the default setting. If for some reason you don't want that solution, you can turn off merge tangent faces. And with unmerge or turning off merge tangent faces, you actually get a solution where those edges are introduced into the boundary surface from your sketches. Another option in boundary is actually the ability to drag sketch. Now you have to realize that this is only available after you first create the boundary. It's more of an editing tool. When you go back into boundary, you can go and turn that on and then start to drag your 3D sketch in various ways. So you get some nice interaction when you're trying to edit your boundary to be able to use this drag sketch feature. It's rather limiting actually, because it only works for 3D sketches, and it only works after you've created it. I actually find in many cases it's just easier to have instant 3D on and just start modifying and then doing Control B to get the rebuild. So, and that can work for both 2D and 3D. So it has some uses, but I find myself not using it that often for that reason. So back to our other model and talking a little bit more about some of the other options. Let's make this full screen and see what else we have here. So as we move down our property manager, we've talked about these. Preview obviously is on by default. Sometimes if you are working on a computer that's a little slower or don't have as good at graphics or just want to get that out of the way, you can turn that off. Usually I have it on. And then the last section is dedicated to showing different types of display. And here you can see I have both mesh and zebra on. With mesh, you get the ability to see some mesh in there to better understand the flow of the surface, especially when it's in a semi-transparent mode. And then on top of that, you can get zebras in there also to evaluate what the matching looks like across the surface. Unfortunately, you can't actually turn the zebra on these surfaces within the feature. At least I don't think you can. Yeah, it's grayed out. So what you probably have to do is go out of the feature, display zebras, and then go back into the feature and start to look at the matching itself. Of course, if we go back into tangency or just none, you can see there's no matching there. And as we turn on tangency or curvature, we get some better matching there. So you have those available to you. You also have curvature combs to see what the surface is doing as you create it. And this can be particularly useful if you're back into the feature itself after creation and dragging a 3D sketch. So those are some of the other properties that are available to you for boundary. So getting back to our sound dock model and talking a little bit more about boundary and how certain boundary features were created. So we talked about the handle here, and that is super important, the way that I did that, because what was important to me was to get some really good curve matching across that boundary, especially if this is done in a high gloss black. As you can see here in this rendering, that connection becomes super important. So you want to pay attention to what the CMF or the color material finish of your model is when you're modeling, because sometimes it can make a profound difference depending on how you build the model and how it's going to turn out in a manufactured product. So moving forward, we talked about this boundary a little bit also, and my final solution on that was just to do a simple first directional boundary with curve matching on these two revolved faces. And with that, I took and trimmed both the bottom and the top just using 2D sketch curves in the front plane. And that turned out to be the best solution, because as you can see with real view on, I get a really nice spherical surface across there and get the definition that I want as far as the edge. And the remainder of this model, at least the main form, is just a few more boundary surfaces that are created. Here's a very simple one where I'm just using the edges of this revolve over on the left side and the right side, and then just using that trimmed edge of that preceding boundary. And here you can see one of the great features of the boundary is that I didn't have to define a second curve. I can just do a single curve in the second, or a single edge in the second direction to get the shape that I want, and that is to be a fairly consistent ribbon going across the bottom. And I move on and fill in this back area. And again, I think, here I am defining a curve for both the first and second direction, 2 curves for each, because this edge is really important to me because I'm going to fill in another boundary past that. So you can hear these are sharp edges, so I have none as the condition of matching, and then curvature across in the first direction. And then I create a interim curve. This curve is pretty important because if we show that, we have a curve here by 2D curves, which is a really cool feature, and it's been in SolidWorks for a long time. And you can create a curve, 2D curve in the front and then in the top, and you get a result in 3D here between these 2 vertices. And then I use that edge along with a second little curve here to create this boundary. So this boundary, we take a look, again, curvature to face. These are sharp edges, so I don't need any matching. And then if I was really particular about this, I would actually, on this interim curve, assign a vector direction so that it was symmetrical across the midplane. So by selecting directional vector and then inputting into this box this axis, or actually I don't know if I have an axis for this. Let's try this guy. Nope. I would have to actually create one. So if I go back before this and pick my top and my front plane, then I can go back in to this boundary. And here, let's turn off our selection manager. Do this by a directional vector. And if I show that, now I can fill that in. So here's the dialog box for that. And I filled that in. Now it's not going to make much difference because these are identical curves, and I've been careful to make these second direction curves pretty symmetrical around the right plane. But it does give a little bit more assurance that everything is symmetrical across this interim curve. So moving on, I think here we are filling in the bottom face right here. Actually, it's the back face. So here I've created some first directional curves through these points. I really wouldn't actually need these 2 points because I'm going to be trimming this away. So if I eliminate that curve and also this one, you can see you get the same result. So those are a little bit redundant there, but I did it to try to keep things as linear as possible. So they're kind of helper curves to make that happen. And then with that, I've knitted a number of these curves together and then did a mutual trim between this this handle boundary and this last boundary that I created. And then with all of that, I've taken all those surfaces and made it a solid body. So that's pretty much the primary form for the sound dock and the boundary surfaces that were used to create it. So with this Impellor model, let's do a little bit of a deep dive on it to show how it was created and how boundaries are used for it. So if we just roll up to some of the primary features, we have the basic center revolve, and then to create the blades, that is done with a single boundary surface, and it's done with first and second directional curves. Again, if we look from a top view and we turn on our sketches, I basically have a bottom sketch with an arc and then a top sketch, which is actually a derived sketch of the first one, but then rotated, because that's really the design intent. And then with those two as our first directional curves, the second directional curves are created by a curve by two directions. Basically, the circular radius from the top view, and then from a side view, another curve that's created. And with those, I'm able to get these 3D curves for the second direction of the actual blade surface. So right now it's just basically a surface, and you can see it follows for a certain point, and then as this falls away it doesn't match. But that's no problem, because this is a separate surface and I'm going to make it a separate body to give it some thickness. So now we have some thickness to that. And then we want to cut off the top because we want a scoop-in feature for the entry of the air. And then there's a few more details to put in some split lines to do some radiuses and other features. And I'm just going to roll forward through some of those. Here you can see that, oh, this is interesting. So to get this kind of radius here, so what we want basically, the reason I put in a split line, and you actually can't see it because we have our tangent edges hidden. So there's a split line here, and what we're doing here with these fillets is we're creating a fillet along this edge, and we're asking it to actually hold to the edge. So let's go ahead and roll forward. And we get that kind of shape for our fillets, a kind of knife edge in the beginning there. And then I'm also doing that on the bottom. So on the bottom, I'm using a hold line fillet that's why I put the split line along this face, and then having it hold to that to do a fillet by two faces. And we do that for both sides. And so now we need to do something to finish out the edge of the blade to make it rather soft and wrap around. So that is another boundary, and let's edit into that. So you can see, let's just roll forward into it and explain a few more things. So I'm going to roll into that feature and then roll back on our sketches and show them. So here we have kind of our open face. So what I did was I deleted the face to make it back into a surface body and remove that outer face. And then I'm building some additional 3D sketch curves. And this one 3D sketch curve will define the apex, if you will, of the edge of that blade. And then I'm going to build a few more curves at the top and the bottom to define those as the boundaries for the boundary surface. So with that, we'll roll back over the boundary and edit it. And you can see that we've defined our boundary surface by those existing model edges and then these second direction curves. If I weren't to include those and just clear those out, you can see you get another solution which is basically only first directional curves. And actually this is a better way to get better matching across this boundary, because as I mentioned before, if you don't have second direction curves, you're just going to get better matching on the first direction because there's nothing that's delimiting it or holding it back from matching because you don't have second direction curves. But in this particular solution, this becomes rather tight down here, and I do want to actually define these boundaries here. So let's edit out of it and look at our solution. That way I can actually fill these much easier with these boundaries defined. So I'm going to go ahead and knit this to the rest of my blade and then do a fill. And that fill that we'll talk about in a future episode is just basically selecting these loops because I knitted it and then applying tangency to all those boundaries. Actually, I put some curvature on some of them, just get a little bit better matching. So we still have the top side to fill in, and this becomes a little bit more challenging because the rate of curvature is rather great, and also you can see that we're going to no matching here on this particular edge. So if we were just to do a fill on this, it wouldn't work. If we go into fill and we actually just say select open loop, we get something rather bizarre. If we try to apply tangency to all of it, I don't think we'll get a solution. Yeah, and that's namely because of this is a very difficult situation here to be able to fill from a sharp edge to a curvature matched or tangent edge here. So we have to do a little bit more work on this corner, and is usually the case when you're doing surface modeling. You've got to invest more features. So what I'm going to do is I'm going to break it down. I'm going to just try to fill the top side and the bottom side separately to try to make it a little easier solution for fill to accomplish. So before I do that though, I'm going to create a reference surface. And if you look at my models, you'll see a lot of these reference surfaces. And they're all basically the same. And what they are is, if we edit into it, I've basically created a 3D sketch of some simple lines that are tangent matched to the existing model edges. Here I've tangent matched that to this edge. I've tangent matched that to this edge. And then this one out here is floating, and I basically am adjusting its angle and position using the 3D sketch triad. So I have those, and then with those and this other curve that I created, I'm creating my boundary surface, which is just basically a reference surface for tangent matching of the fill that I'm going to create. So very simple to create, but completely necessary for fill. So our next feature is filling in that surface. And just to illustrate, if I did not have matching on this edge here, we'd get a very bizarre fill surface. And I'm finding more and more often than not, that fill works best if you do matching on all of the boundaries. Unless the curvature is very slight and it's a very flat surface, you can get away with just doing contact. But on more complex features like this, you want to try to get matching on all the boundaries, and that's the reason for the boundary reference surface. So, and that's the reason I did it. But I'm kind of getting off topic here. I'm going to talk a lot more about fill in a future episode. So here's our reference surface. We can hide that. And then we're going to create another boundary underneath here. And here I've created a boundary surface using an additional 3D curve here. And by doing that, I can make it a regular four-sided boundary. So here are my second direction curves. Here are my first direction curves. And then my final step is to knit all of it together and then do a fill with make solid at that corner. And that's basically the solution to getting that impeller blade with that kind of final definition at the top. And then of course I can take that multi-body and pattern it by whatever increment I want for my propeller blades. I can do a little bit more of a move face on the bottom. I think I'm doing some ribbing in here. And then finally, I'm going to combine all that into a final solid form. And that's how the impeller blade is created using boundary.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project, or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.